Hi, everybody. We're going to go ahead and get started for today's session. My name is Huy Nguyen with Nebula's Product Management and Marketing team. I have with me also as well is Dr. Bryan Payne, who will be our speaker. Dr. Bryan Payne is just some very quick background on, Bryan here is that he's our security director at Nebula, and he's also the co-founder of the OpenStack Security Group. Bryan also authored the OpenStack Security Guide and many research papers on virtual machine introspection. Bryan is also the creator of libVMI, which is an open source software library for runtime monitoring of virtual machines. But more importantly is, Bryan's background comes from a very esteemed set of roles. So prior to joining Nebula, Dr. Payne worked at Sandia National Labs, as well as the National Security Agency, BAE Systems, and IBM Research. So for those, we just see that some more folks are signing in right now, but before we start, what we like to do is launch some questionnaires or polls that we like to have you guys just quickly answer. So the first question is, what is your largest private cloud security concern? So we'll just take a couple of seconds here to allow you to answer that. Okay. So interestingly enough, right, so we just want to share the results of that first question here. So instance level security is up top of mind for all the attendees that are on the webinar. We're going to launch two more questions here. The second question is around what OpenStack security project most interests you? Okay, we're going to close that poll real quick and share the results. And it seems like the Barbican key management is top of mind, so very interesting. And then the last question, what best describes your role with private clouds? And then after this question, we'll go ahead and get started and pass it over to Bryan to go over and share his esteemed knowledge around private cloud security. Okay, we'll go ahead and close this last poll here and share the results. And it seems a lot of the folks attending the webinar are administrators, and that's very good to know. So with that in mind, I'm going to go ahead now and pass it over to Dr. Bryan Payne and walk through the knowledge of security and how it applies to private clouds. Bryan?
All right, thanks, Huy. So just to get started here, I suspect that we have a pretty well self-selected group, and you're here today because you're interested in security with private clouds. But I think a fair question to start off with is why security matters in a private cloud. I get this all the time. I hear people saying security matters in public clouds because it's on the internet, but at my corporation, my cloud sits behind a firewall, and it shouldn't be a concern. So let me motivate this a little bit, and hopefully by the end of the presentation here, you guys would all be able to answer this for yourselves anyway, if you can't already. So I would argue that security is, of course, important in private clouds, although it's sometimes quite a bit different from a public cloud in terms of what your security concerns are and what you're protecting. Just because it's behind a firewall doesn't necessarily protect you, and we'll walk through some reasons why that's the case later. But more to the point, private clouds are typically stood up for business reasons. They're running important business applications. There's important data there. And often there's important segues into the rest of the corporation or the rest of the organization that's using the cloud. And for those reasons, security on the cloud is just as important, if not more important, than security for desktops and all the rest of the services that you're running throughout the enterprise. So what do we mean by private cloud? So if we look at a formal definition from someone like NIST, they keep it pretty high level, right? So they're going to say that a private cloud is basically something that's provisioned for exclusive use by a single organization, whereas a public cloud is going to be something that's available to the general public. And I like to think of this as a public cloud. If you have a credit card, you can use it, right? A private cloud, you need some sort of ID badge to be able to use it. So you're some sort of member. And I think that's a true distinction. However, I think when it comes down to it, when you start deploying private clouds for the purpose of an organization, you'll find that the way that they get deployed and the way that they get integrated with that organization turns out to be fundamentally different than how a public cloud may integrate with you. And because of that, there's going to be greater differences and greater security concerns. Okay, so just to dig a little bit deeper here, of course, we have the internet, which we're all familiar with, and I just list here the top 10 websites on the internet, at least as of the time when I made this presentation a little bit ago. And then we have our private network, right? And this private network could be inside your corporation, it could be inside some sort of organization, however you have things set up. But within there, you probably have a variety of IT pieces set up, right? You have quite often a PKI system. Almost everyone sets up DNS, email, things like LDAP for your authentication, logging solutions, all around the board. There's just sort of standard things that we tend to set up as we set up our private networks. Now, when you think about a cloud coming into that private network, what you tend to see is that the cloud doesn't exist as an island all by itself, but instead it needs to integrate very deeply with this ecosystem that already exists. In fact, that is what makes the cloud useful for someone who's deploying it, and that is oftentimes the reason why someone wants to deploy a private cloud. For example, think data locality. You might have large amounts of data that you don't want to ship up to a public cloud for processing, or the data itself may be security-centric, right? There might be HIPAA concerns, there might be just general security concerns for your corporation, you want to keep it local. And so as you deploy a cloud within an organization, you tend to integrate it deeply with all these existing services that you have. In fact, you would expect this, right? You would expect that the cloud can log to your existing logging systems. You would expect that you could log into your cloud using your existing LDAP or Active Directory systems. You might sync the cloud's time using your existing NTP systems, and so forth. And so as you deploy this, it becomes another piece of the IT infrastructure, and it becomes deeply integrated. Now, why does this matter from a security perspective? Well, I mentioned previously that simply sitting behind a firewall is not going to be enough to protect most of these systems. And I think anyone that's been working with IT security for a while now will not be too shocked to see that this is the case. Firewalls are certainly a useful tool, but as we've learned over the years, there's a lot of ways an attacker can get into systems that basically bounce right through a firewall. As one example, let's imagine a sort of modern style phishing attack where you simply send out a spam campaign or maybe a targeted email campaign to particular users. You convince them to click on a link, and through that, you're able to exploit their system. Well, at this point, you're running code on that particular user's system, but that user's system is behind the firewall and has access to the cloud itself. And so you leverage that access as a stepping stone to hop into the cloud. And once you're in the cloud, you may be able to do some additional exploitation and maybe even get from the cloud to a corporate service that has some value to you. For example, straight over to the LDAP service. And so it's scenarios like this that make me think that when you deploy a private cloud, you definitely want to be thinking about security. You definitely want to be thinking about how do you integrate with the rest of the corporation so that your cloud itself doesn't become a weak point in your network. Okay, so let's take a step back and let's think about who are these bad actors, right? Who might be coming to attack your network? And I pulled this particular diagram out of the OpenStack Security Guide, but I think it's a nice general overview. You can see sort of the width of this triangle as the likelihood that a particular group might hit you. And I don't mean the likelihood that someone's going to succeed, but just this is a measure of the volume of attacks going on from these groups. So down at the bottom we have script kiddies. If you're not familiar with that term, that's basically your average Joe hacker who happened to download an exploitation tool that they don't know anything about how it works, but they're just going to push a button and see if they can make it work. And then you've got people that are a little more motivated. Maybe they can do some programming themselves. Maybe they are actually going after something particular in your organization. All the way up to highly capable groups, serious organized crime. These are groups that are very technically savvy. They know exactly what they're after. Often it's just a mechanism for making money. So more computing resources allows them to have bigger spam campaigns, bigger botnets, etc. And then at the very top, we've got the intelligence services, who have certainly been in the news quite a bit lately. And they have sort of an interesting role to play here because often they're after things that are not necessarily a financial motive, although sometimes they are. We hear everything about various corporate espionage things happening there, but also just general intelligence gathering. And so as someone who's responsible for security at an organization who's standing up the cloud, I would urge you to think a little bit about who is it that you're trying to defend against. Because as you walk higher on this triangle, you're going to find that the sophistication of attack goes up. And frankly, the likelihood that they're going to get in goes up. And so if you are worried about keeping serious organized crime out and intelligence services out, then the level of security that you need is going to be much more sophisticated. And that's something that you're going to want to take into account as you build your systems and as you do your threat modeling. So what does that threat modeling look like? How would you start to piece these pieces together? So what I've done here is try to provide a little view into how I would go about thinking about security in a cloud that I'm standing up. Now this is, if you will, just a very small slice of what would be a much, much larger picture. But the idea here is to give you a sense of how this would come together. And what you would do is you would start either on the left or the right side. But let's start on the left for discussion today. You would look at all the different ways that an attacker could get into your system, right? So that, like we said earlier, they might compromise a user's system. They might be able to directly compromise an instance in the cloud. There might be other ways in as well, and you could enumerate all the different things. And then what we'll do is we'll say, well, what could they do from that vantage point then, right? So once they've compromised an instance in the cloud, what could they do? Perhaps they could access the cloud as a user at that point, right? And they might be able to use that access to elevate their privileges to other parts of the cloud, either through a vulnerability in a cloud API, through a virtual machine breakout attack, or through something else. And we'll talk about what these kinds of vulnerabilities look like later on. From that point, there's all sorts of interesting things they could do, depending on how the cloud's constructed and how pervasive their access is to the cloud. And so then you can just start to peel the onion layers back and back until you can see all the different things they can do. Now, the interesting thing about an exercise like this is this is called attack modeling or attack trees. What you can do is you can start to say, well, where are these critical points in my graph? What do I need to stop an attacker from doing to prevent them from getting into the pieces I care most about? And what you will probably find is that there's certain parts of the cloud that turn out to be more critical from a security standpoint than other parts of the cloud as you start to do your modeling. And then when you build a cloud, you want to look at those parts and figure out what can I do to harden them, to make them more resilient against attack. And typically the right answer isn't just one thing. but it's multiple things. And so you will take what we call a layered security approach, so that an attacker doesn't have to defeat one lock on their way in, but they have to bring their lockpick kit plus a crowbar, plus a door smashing thing, plus some explosives. You want them to use all the tools in their toolbox before they can get through. And that's how you want to defend those parts that are most critical for the portions of your cloud that you care most about. Now, there is some good news here. When you're building on a cloud, you're actually working in a space where security, I would say, whether or not it's easier, but certainly there's some more opportunity to do security right. And the reason I say this is because we're living in a world now with a bunch of orchestration tools. So I saw several of you identified as either developers or cloud administrators or operators. So you're probably familiar with things such as Chef, Ansible, Puppet. These are just sort of the tools of the trade that we're using to deploy things to stand up services in a cloud. The nice thing about these tools is you can automate how things are stood up, and you can make sure that you do it consistently every single time. This is a wonderful thing from a security standpoint. You don't have human error. You're not going to forget to configure a service on one machine when you configured it on the other 100. You can automate it and make sure it's done properly and then deploy it. The other piece that can help you quite a bit here is that as you're rolling out a cloud, you basically know what your hardware is. In fact, often it's somewhat consistent throughout your cloud. You might have purchased a small number of models for all of your hardware models for all of your cloud nodes, and then you can build on top of that, leveraging specific features in that hardware, for example, to get better security for your cloud. Same thing with the software that you're deploying. You're going to deploy similar software throughout your cloud because it all needs to work together, and you're going to be able to configure it in a consistent way. So all of this comes together to create an interesting opportunity where I would argue that if you're used to traditional IT security where you're securing desktop machines that are extremely heterogeneous throughout an organization, securing a private cloud actually affords much more opportunity to get things right. And this is where we can leverage all of the good knowledge that we have to do things well. So how should we do it? There's lots of right answers. I put sort of a high-level diagram here just to get you thinking about the different pieces of the cloud, how they fit together, and the most important thing about this picture is how we would break the cloud into different security domains. And so that's the different colors that I've got. We have what I'm calling the external security domain, which is sort of a red hash mark color in my screen in the upper left. We have the data domain, we have the guest networks, and we have a management domain. So let's look at what each of these are like. In the external domain, this is who can access your cloud from outside of the cloud. So this might still be behind your corporate firewall, but this would be people that are using the cloud. They can access the API endpoints on the cloud. They can access instances that have external floating IPs on them. Then we have the guest network. The guest network is typically a dedicated network on your cloud that is not externally accessible, but all instances can communicate with each other on this network. And then we have a couple of different security domains that I show here for management functionality. So the control plane typically is on a separated network. All of your data access is typically done through a separate network. And in fact, the control plane and the data access, these could be broken into many, many additional networks. You could imagine an out-of-bounds management network for provisioning your nodes, different networks for switch management, these kinds of things. And the idea here is you're separating concerns. You're separating out your security domains so that what you can do is you can look at the boundaries between these domains. For example, your API endpoints represent a boundary between the external network and the management network. And that boundary is a point where an attacker could actually elevate their privileges if there were a vulnerability in the cloud. And so because of that being a concern, we would want to take those boundaries into special consideration and make sure that they're properly secured. And so by drawing out your architecture in a way like this, you can start to identify where those locations are and where you need to have extra attention given to your security. If we go down a little bit deeper, now this is sort of an OpenStack-centric view because that's the world I play in right now. The idea is basically the same for any sort of private cloud, where you're going to have a set of core projects that provide your core cloud services. In the OpenStack world, we have compute, networking, storage, there's authentication services, there's a web dashboard. All of these things are going to come together and be sort of the user-facing pieces of the cloud. This is how people access the cloud. This is what they think of as the cloud every single day. And of course, for the reasons I just mentioned, you need to be very careful with these services and lock them down because they are accessible to users and because they can serve as bridge points to bridge the gap between different security domains. However, we shouldn't forget about all the rest of the stuff, which I'm calling the glue. And these are pieces that you'll find in the news frequently as having security problems, things such as OpenSSL, things such as KVM, your MySQL database, your Apache web server, your RabbitMQ message queue platform, Linux, and the list goes on and on and on. Now, the things you use for glue are going to be different depending on how you've deployed your cloud. But typically with an OpenStack cloud, you end up with a list that looks something like this, and it's probably much larger than this. And each of these pieces serves as a supporting role to make sure that your cloud is operating properly. Some of them are more exposed than others. And so you need to be careful about how all these other pieces are actually exposed in your cloud and take them into account in your threat modeling. Just as an example, we've been talking a lot about OpenSSL vulnerabilities in the news lately. In fact, for those that are paying attention, you might have noticed there's going to be another vulnerability announcement tomorrow, and everyone's sort of on the edge of their seats to see how bad it's going to be. So when something like that comes out, it's important that you understand the impact of those vulnerabilities on your cloud. You understand how OpenSSL is used in your cloud, and you can take proper mitigation strategies. For this reason, one of the really important things that you can do, no matter how good your architecture is to make sure you have a good upgrade strategy. Because there will be problems with the software, and we're all human. There's going to be problems with your design and setup. And so at the end of the day, you're going to want a way to evolve to a better design from a day-to-day standpoint. So upgrading, security patching, et cetera, these are very critical pieces for the life cycle of your cloud. Okay, so now this is when we sort of hop inside my mind and give you a little bit of a sense of how do I apply some of these skills to a private cloud to end up with what is hopefully a more secure result at the end. The way that I like to go about this is to take a look at the various attack vectors into the cloud. These are some of the bridge points that I mentioned before, but they can also be just sort of more general security concerns as well. So we have the API endpoints, which we discussed, the web dashboard, a more general concern of information leakage. You might be concerned that someone accessing an API endpoint could leak information across the network, and you want to think about how you do that. Or you might be concerned about two virtual machines, two instances, sharing resources on the same compute node, and there being some sort of leakage between the two because of the nature of virtualization. These are the kinds of things you might want to be thinking about there. VM breakouts is basically when you're running inside a virtual machine and you can do an exploit that actually lets you run on the host underneath that virtual machine. So of course in a cloud scenario, a VM breakout is a very serious attack because you would be elevating from your instance into the control plane. Other concerns such as hardware sharing, default images, and secondary attacks are certainly worth considering as well. So for each of these, what we do is we can do a bit of analysis to understand the nature of the threat and more specifically the nature of how you can stop that threat from being a problem for you. So let's look at information leakage, and we'll walk through just a few of these for examples. Here I would just say that TLS is your friend. We've talked about OpenSSL and how it's been in the news for security problems quite a bit lately. But that doesn't mean we shouldn't be using it. And of course, you can do TLS with other libraries too, if you so choose. But the point with TLS is that it allows you to encrypt your network communications. And when you're talking cloud, you're talking API endpoints that people are going to be communicating with and passing sensitive information on. That information could be credentials to log into the cloud. It could be tokens that give them access to the cloud after they've logged in. And it could be much more information as well, like their actual data for the cloud, their storage data, et cetera. All of that information really needs to be protected, and it needs to be encrypted as it goes across the network, and TLS is the best way to do that. You might notice that I'm saying TLS and not SSL. SSL is basically deprecated at this point. As of the Poodle attack that came out several months ago, the last version of SSL, SSL v3, is no longer recommended for use, and everyone really should be up on TLS. So this can protect your API endpoints, it can protect your web dashboard, it can even protect things like your log feeds, your connection to your Active Directory system, and external storage. Anywhere that TLS is an option, you should be using it. And more so, remember that TLS is one of those nasty protocols that's really challenging to deploy properly. So take some time to read up, and the OpenStack Security Guide is probably a good option for reading up on it and learning more about how do you actually do this properly. Finally, another threat for information leakage is cross-VM attacks. So for those that aren't aware, this is a little more subtle, but I mentioned it earlier. If you're running two virtual machines on the same node, there's some interesting timing effects and some interesting cache effects. And the academic literature has showed that in certain circumstances, you can do some rather devastating attacks using this technique. You can actually extract encryption keys from a different VM that's running on the same host that you are. Now, this is attacks that are basically inherent all the way down into the cache of the hardware that you're running on. And there's not a whole lot that you can do as a cloud deployer to stop this. However, this gets to multi-tenancy. This gets to how do you actually go about scheduling your instances to make sure they land on the right system. And if you have extremely stringent security concerns, you might want to explore making sure that your instances in a multi-tenancy situation are not shared with other, are not sharing a host with other instances that you don't necessarily trust. Okay. Of course, the other threat when you're running in a virtual machine is the virtual machine breakout attack that I mentioned earlier. What can you do to stop a VM breakout attack? Basically, this has to do with a code flaw in your virtualization layer. And there's a few things you can do here. You can actually harden your virtualization layer to make it harder to attack. There's compile time options for things such as QEMU, for things such as KVM, that make these systems harder to exploit, and they're certainly worth exploring. In fact, a lot of your common Linux distributions already enable these sort of hardening flags when they build their systems today. And so you might be benefiting from that without even realizing it, which is even better. Something else that you can do is you can deploy mandatory access controls. This is stuff such as SE Linux. You might be familiar with AppArmor as well. What these will do is constrain a virtual machine and all of the code running within a virtual machine to a narrow set of things that they can do on the host itself. So in the event that a breakout attack is successful, they are still operating within the confines of these SE Linux policies. And what that means is that an attacker might be able to break out, but then they can't actually go anywhere or do much harm. And so this is the case of having layered security, where you might want to have a hardened virtualization system and then really strict policies to prevent someone from getting out any further if they do get past your hardening. Given that VM breakouts can be really devastating to the cloud, if security is a concern of yours, it's probably worth spending some time taking all these measures into account. Other things that are certainly worth doing in a similar vein here include general node hardening. So things like SE Linux and AppArmor are only going to work if the kernel on your node is still running the correct version and is still secure. Using things like boot time attestation to verify that your system came up properly using a hardware root of trust, such as the TPM, can help you out quite a bit here. The next threat we'll consider is the control plane compromise. This can be a general compromise of the control plane through any means. We just talked about the VM breakout as one way to get there, but certainly someone could bust through a firewall in your cloud, could get into your control plane through API vulnerabilities, etc. One of the things you want to be very careful here is to make sure that your cloud doesn't have one of the classic security problems, which is a hard outside and a soft and chewy middle. So if someone gets onto your control plane, what can they do from there? Hopefully the answer is, well, once you're on the control plane, you have full access to everything and you can own the entire cloud. A better answer would be, well, maybe you compromise a single service on the control plane and that gives you very narrow access to your cloud, but to get anywhere further, they would have to continue compromising additional services. When you build your system, that's how you want to be thinking about things. Limiting the propagation of sensitive data, make sure everyone's using unique secrets. Every person that's, or every process that's accessing your database should have unique credentials to get in. That's good for layered security, but it's also good for auditing as well, because you always know what services are accessing the other services at any point in time. And finally, all the classic things that we just mentioned before, TLS, SE Linux, boot time attestation, all these things come together to build you a really solid foundational root of trust. Upstream vulnerabilities. I think everyone probably understands this one pretty easily. We mentioned it earlier that if you deploy a cloud, there's a lot of software involved and there will be problems down the road. And so just make sure that you can push out these vulnerability fixes, the security patches, as quickly as you can. You probably want to be thinking about how can you test them quickly on maybe a secondary system to make sure they're not going to break anything, and then how can you quickly roll them out into your cloud so that the time from the patch availability to the actual patch getting deployed is really as small as possible. And the last one that I'll mention is covering the area of instance security. I know that that was a concern a lot of people mentioned at the beginning on our poll. Instance level security has many facets, and oftentimes the answer is simply apply the same best practices that you do for any other desktop in your enterprise. But there's challenges, of course, because instances are typically managed by the person that's deploying them, and you may or may not trust them like you would your professional IT staff to secure things properly. There's all sorts of strategies there that you can use, such as provisioning trusted images into your cloud, giving people guidance about what they need to do to make sure that their instances are properly secured, and doing rich auditing of those instances to make sure that they've done things properly. However, if you don't have a solid foundation to build from, then all of that is really for naught. And one of the foundational pieces that you need is good entropy. If you're not familiar with entropy, this is nothing more than random numbers. Random numbers are very important from a security perspective because that's how you generate keys and that's how you set up secure connections. So if you're going to deploy an SSH service into an instance, it's going to need keys and it's going to need entropy for that, and it's also going to need some entropy as you establish a connection with that instance. Same thing for TLS connections. There's some random numbers that are used to set up the connection when you do your initial client-server handshakes, and entropy is important for those. Without a good source of entropy, all of these common constructs that we use tend to fall over. And what's interesting is that it's typically very difficult to get high-quality entropy into an instance in the cloud. So this is something that's worth some special consideration when you're building out a cloud. These days, with modern processor architectures, you have things like the RD-RAND instruction that gives you a very high bandwidth, high quality entropy source. There's also a pretty large number of hardware entropy generation chips that are available, RNG chips. All these come together. You can actually get a good source of entropy in your cloud, and then it's a matter of plumbing it into the instances so that they can make use of that entropy. Once you do this, once you do some of the other things we talked about here today, your instances will be coming up with a secure foundation, and then it's just down to all the classic things that you're used to doing in a traditional IT setup. So taking a step back and putting it all together, hopefully you'll see now that private clouds really do need security, and they need attention to security. And oftentimes, if you're in an enterprise environment, your private cloud is going to have somewhat unique security concerns. This comes through the deep integration with existing enterprise services. Clouds are very well suited to doing this security, but you need to step back and really be thinking about it to make sure that you do it properly. So the tools are there, the information's out there, and I think attending this seminar today is a great way to get a leg up and learn some of the foundational pieces that you need. So I encourage you all to apply this and be careful out there as you secure your clouds.
Great, Brian, thank you. I think, when we look at all the information that Brian presented, it's a great way to look at, a view of inside as well as outside, but more importantly, is highlighting the security guidelines to secure a private cloud. It's also very important to say here, Brian, if I can share this, is that all the security guidelines that you highlighted is pretty much built into our Nebula product foundation for the private cloud. And we've heavily invested in security. We believe in the security is very important, especially when building out private clouds. And we've also invested in a team that you run here to also quickly respond to these threats as they continue to occur out in the market. Anybody out there that's trying to sell a product to say that their product is the most secure or is unbreakable, I think those folks are pretty much trying to sell you a used car, right? Every product is eventually going to hit some type of vulnerability, and more importantly is how fast we respond to it. So want to quickly tell how fast we can patch vulnerabilities with the team that you have in place?
Sure. So we assess vulnerabilities as they come in and keep a really close attention to all the upstream sources. Like I mentioned, knowledge of this OpenSSL thing that's going to be coming out tomorrow, and we just assess each of those from a security impact to the system. And when there is a critical thing that comes out, we've turned those around in 24 hours and gotten patches out to our customers because we believe that that's an important piece of the security story.
Yeah. So we have some questions online here, and we'll just pick some of them and get your thoughts and as well as your input here, Brian. One of them is, which threat actors do you think are the biggest concern?
Yeah, that's an interesting question because I think everyone's sort of thinking about security from the perspective of just go harden everything. And we don't have endless resources, right? So we need to be able to be thinking about what's the most important thing to harden, and frankly, what are the capabilities of the people that are coming after us? Yep. And so if you think about your threat actors and who you want to be worried about, it's going to vary based on each company. But what I will say is that if you look at over the past 10 or 15 years, the people on sort of the top half of that pyramid that I showed earlier are getting very, very good at what they're doing. And in some ways, their skill sets are starting to come to grow together. And so even if you say, oh, I'm not worried about a nation state coming after me, some of those second and third tier groups are strikingly good. And I think you need to still be thinking quite a bit about how you secure your stuff for them.
Great. Second question here is kind of common. What are the next big things in private cloud security?
So taking this from more of an OpenStack vantage point, it's been interesting being part of the OpenStack security group. There's a flood of activity going on in security in the cloud. One of the really interesting developments that I've seen of late is the use of ephemeral PKI. There's a project called Anchor that people are starting to work on. It's in very, very early stages. But what this really means is moving from a world where you buy a certificate that's good for 2 years to a world where you generate a certificate that's good for 2 hours. And and it's very nicely suited to a lot of cloud applications, particularly the control plane of the cloud as you're locking down these services. It removes things like needing to worry about revocation and turns it over to a reissuance problem for certificates. So if you're looking at deploying things, I think things like ephemeral PKI are very exciting for deployers.
Got it. Then lastly, where can attendees find more information about deploying a secure private cloud?
Sure. So, of course, you can always contact Nebula for more information. We're always happy to talk about security. It's one of our favorite things. Another resource that I would point people at is the OpenStack Security Guide, which I was one of the lead authors on and have maintained for quite some time. It's a great resource. It's available for free. It's part of the OpenStack documentation effort. If you just Google OpenStack Security Guide, you'll find a lot of the information I discussed in the talk today presented in great depth, and it can help you on your deployment strategies.
And then for those, we got some more questions coming in. We'll also post that online too as well with the Q&As. But we do thank you everybody for taking time away from your busy schedule to attend Nebula's Security Private Cloud webinar. And thank you, Bryan, for taking time away from your busy schedule from monitoring all the threats out there for the private cloud and educating us. So thank you, everybody. We look forward to the next webinar.